Welcome to lesson 5.4 on the sine law. So, in lesson 5.3, we learned about our primary trigonometric ratios, and one of those ratios was sine, which was opposite over hypotenuse, which was very useful if we had a 90-degree angle in our triangle, or in other words, if it was a right angled triangle. What we're going to learn today is what to do when we don't have a right angle triangle. And so this first part's going to be a little bit of a proof on the sine law. So if you don't understand the proof, that's okay, as long as you're understanding how to apply the sine law, which we'll do with some examples a little later on. So we learned to use SOHCAHTOA when we're working with a right angled triangle, but what should we do if there is no 90-degree angle? And the answer to this is, as long as we have three pieces of information, we can use either the sine law or the cosine law, which we'll be learning in the next lesson, in order to find any angle or side of that triangle. First, we're going to start off with a little proof here. So, in my triangle ABC, we can see this big triangle doesn't have a 90-degree angle in it. So remember, this is a proof, so if you don't follow it, that's okay. What I'm going to do is I'm going to put an altitude from vertex C, and it's going to join line AB at a perpendicular or 90-degree angle. So I put in our little indicators here, just showing that's a right angle triangle. And now that I've done that, I'm going to prove the sine law. First off, notice how the triangle is labeled. Each vertex is in a capital letter, so A, B, and C. And each side that's opposite the vertex is the corresponding lower case of the vertex. So here we have vertex A, which is our angle, directly across from it. And yeah, I can even draw that. You're going to see directly across from that we have lowercase a. So once again, vertex B, directly opposite vertex B, is line length little b. And we can do the final thing for C. Vertex C, if we go directly across, we see little c here, denoting that line length. So sides and angles opposite them have the same letter. And there's a reason for this, and that's because they have a relationship. And we're going to prove that relationship. So, I couldn't do anything before, but I can use trigonometry now that I've put this altitude in. Now that I've put the altitude in, I can notice some things. So, here's what I can notice. In the above triangle, we can see sine A is equal to opposite over the hypotenuse, which is h over b. And I'm just going to go back to my triangle. So sine of A equals, let's just clear that up by getting rid of those. The sine of angle A, so there's angle A, is opposite over hypotenuse. So our opposite is h, the hypotenuse is b. It's opposite the 90-degree angle. I can do the same thing for sine b. Sine b, so let's just pick a slightly different color here. Sine b is going to be opposite over hypotenuse, so it's going to be h over a. We're going to use those concepts here to prove the sine law. So, sine A equals h over b, and sine b equals h over a. So, what we can do is we can actually rearrange this a little bit. So, we'll start with this one here. I'm going to multiply both sides with b, just so I know exactly what h equals. So, b sine A equals h. I'm going to do the same thing over here. A times sine B is going to give me A sine B equals H. Now they both equal H. So what does that mean? Well, that means that B times sine of A equals A times sine of B. Not only that, but we can actually do a little bit of algebra here. So if we divided both sides by A would cancel out here. We just have sine B. And over on this side, we have B times sine A over A. And then we divide both sides by B. The B would cancel out here and end up as the denominator over here. So what we would be left with is sine A divided by side A is equal to sine B divided by side B. And we can even extend this further had we done an altitude from uh, vertex B or vertex A. We'd also see that sine C divided by little length c is equal to sine b over side length b and sine a over side length a. So this right here is our sine law. And really what it's telling us, if we just go back here, is the angle and its opposite side have an equal ratio amongst every angle in its opposite side. So the ratio between sine A and A is the same as the ratio between sine B over side length B. And that's the same as the ratio for sine C divided by side length C. They all have the exact same ratio. So what's really cool about this is if we have three pieces of information that we can fill in for any of these, then we can find the fourth piece. And eventually we can use that information to solve the whole triangle, find out every angle and every side. So we're going to apply this to this example here. Solve for the missing side using the sine law. So here we've got a triangle, and we can see it definitely does not have a 90-degree angle. But that's okay because we know that the sine law works for triangles that don't have 90-degree angles. So we see 37 degrees directly opposite that. We know that side length of 4. We see 45 degrees, and directly opposite that is our unknown side. So I'm going to actually call that side, I know it's called X right now, but just to keep constant with our formula, I'm going to denote it as little b. Now, in order to solve for this, we just use our ratios. So sine A over side length A is going to be equal to sine B divided by the side length of B. We know angle A, we know angle B, and we know side length A, so we can fill in this formula. So sine A is 37 degrees. The side length directly opposite that is 4. So that's where we get sine 37 over 4. We're going to set that equal to sine of 45 over the corresponding side length, which is b, or x in this case. Now, when we've got this, there's multiple different ways we can solve this. You could figure out sine of 37, then divide it by 4, and then you'd have one number on your left-hand side. Multiply both sides by x, and then divide by whatever sine 37 divided by 4 equals on both sides, and you'd find out what x is. But there's a simpler process called cross multiplication. So we're going to cross multiply. And when you cross multiply, what you do is you take the numerator on the left hand side and multiply it by the denominator on the right hand side. And you're going to set that equal to the denominator on the left hand side times the numerator on the right hand side. So literally, we're crisscrossing here. Crisscross applesauce. we're going to do those two terms multiplied together and set that equal to these two terms multiplied together. So when we cross multiply, well, sine 37 times x is going to give us x times sine 37. We're going to set that equal to 4 times sine 45. Now we're going to solve for x. In order to do that, our first step here is to find our decimals. So we're going to, in our calculator, put 37, then hit the sine key. And that should give us 0.601815. Remember, if it does not give you that value, double check to make sure your calculator is in degree mode. If it's in radians mode, you're going to get a totally different answer. And on this side, we've got 4 times, well, the sine of 45 will equal 0.707107. So now we're just going to keep doing a little bit of algebra here. On the left-hand side, we've got 0.601815 times x. And on the right-hand side, 4 times 0.707107 is equal to 2.828427. Now I'm just going to divide both sides by 0.601815. Left-hand side, I'll be left with x. And on the right-hand side, I've got this wonderful, wonderful fraction here. So I'm just going to take 2.828427 and divide by 0.601815. And we'll find out that x equals approximately 4.7. So the length of the missing side is 4.7. And that's how we can apply the sine law in order to find side lengths in non-right angled triangles. All right, 2 more examples. The concept's going to be the same for both of them, though. For this one, though, we want to find the missing angle using the sine law. So we have our triangle all set up. We have 52 degrees, and directly opposite that is 100 for side length. And here we have our unknown angle. Directly across from that, our side length is 75. So we can set up our sine law exactly like we did before. And then we're going to just solve for x. I encourage you to pause the video and try that yourself. And then resume the video after you've done it to see if you were on the right track. All right, welcome back. Let's take a look at this. So we're going to use the sine law to solve for this missing angle. And I just have to make sure I set up my ratios correctly. So remember, sine A divided by side A is going to be equal to sine B divided by side B. Well, here I'm going to use this as A, so I'll actually label this. This is going to be vertex A, and this is going to be side little a. This here, let's just grab a different color, is going to be angle B, and this will be our side length of little b. So now what am I going to do? I'm going to make sure I set up my sine law accordingly. So sine 52 over 100 equals sine of our unknown angle B divided by 75. And we should see that from up here. Oh, sine of 52 divided by the side length of 100. Yep, that's my opposite side. That's how I know it's little a. And that's going to be equal to the sine of my unknown angle divided by the side directly opposite that, which is little b, and has a side length of 75 units. Now I'm going to cross multiply. So remember, numerator from the first one times the denominator in the second equation. So we get 75 times sine of 52. And that's going to be equal to the denominator in our first ratio times the numerator in our second one. So 100 times the sine of b. Now we're just going to simplify this, and then we're going to eventually solve for b. So sine of 52, when we do that in our calculators, it's going to work out to 0.788011. So 75 times that is equal to 100 times the sine of b. We can find out what the left side equals, and 75 times 0.788011 should give us 59.100807. And we want to get the 100 out from the right side, so we're going to divide both sides of the equation by 100. So my left side now looks like 59.100807 divided by 100, and that equals my right side, which is sine b. This should start to look like a familiar question from the last lesson now. We don't know the angle. We're going to have to use the inverse of sine to find that. First off, we have to figure out what our decimal is on the left-hand side. So 59.100807 divided by 100 is just going to be 0.591008. And I'm going to divide basically both sides by sine here. So now we're going to get the inverse of sine times that decimal is equal to our angle B. Remember, on your calculator, in order to do this, most calculators you'll have to do 0.591008, hit your second function key, and then the sine button, and that should give you the proper angle. When we do that, we should be getting 36.23 degrees equals B. So we can say the missing angle is 36.23 degrees, or we could probably say is approximately 36 degrees. All right, one more question to look at here, and it's going to be a word problem. A lighthouse keeper spots an iceberg. The captain of a ship also sees the iceberg. The diagram shows their readings. How far is the ship from the iceberg? Express your answer to the nearest mile. So if we take a look at our diagram here, we see the iceberg's over here, the ship's here, the lighthouse is here. We want to know how far the ship is from the iceberg, so that is little d here. And what we know, well, we know 55 degrees is the angle between the ship and the iceberg. 42 degrees is the angle between the lighthouse and the iceberg. And we know the distance between the lighthouse and the ship is 35 miles. We're going to have to do a little work first before we can use the sine law, because right now we don't know an angle and its opposite side length. We know this angle, 55 degrees, but we don't know this side length. We know 42 degrees, and we don't know this side length. That's the one we're looking for. And here we know a side length, but not an angle. So step one for this problem is we're going to use our properties of triangles in order to figure out the missing angle. I just called it I here. And in order to do this, we have to remember that a triangle, if we add up the three angles inside a triangle, it must equal 180 degrees. So in this case, we know interior angles have to add up to 180. We know two of them. That means we can find our third angle. 42 plus 55 plus I for iceberg, that's why I labeled it I, is equal to 180 degrees. So we can just rearrange this and solve for I. So I is actually equal to 180 minus 97, or that missing angle is 83 degrees. So 83 degrees. So let's just write that in there. I'm just going to use this. So that works out to 83. Whoa. Not the best degree sign, but you get the point. 83 degrees. That's that angle. Now we know an angle and its opposite side length. Now we're ready to apply the sine law. We're going to use the angle of 83 degrees and the opposite side of 35 miles. And we're going to set that equal to, well, since we want to find d, the sine of 42 degrees over d. So that's step 2, use our sine law. So sine of 83 over 35 is going to be equal to the sine of 42 over our unknown length d. Same process now as before. We're just going to cross multiply and then solve for d. So d times sine of 83 is equal to 35 times the sine of 42. Let's go ahead and work out what those decimals are. Sine of 83 is going to be 0.992546 times d is equal to 35 times, well, sine of 42 at 0.669131. All right, we can consolidate what's on our right-hand side, and then we're going to divide by the decimal here in front of d to solve for d. So 35 times 0.669131 should give us 23.419571. We're going to divide that by 0.992546 so we can solve for d. So we just divided both sides by the coefficient in front of d there. Now we're just going to solve that, and we'll find out that d equals 23.6 approximately. However, the question wanted us to put it to the nearest mile, so make sure in your therefore statement, therefore, the ship is approximately 24 miles away from the iceberg. And that's the sine law. So that's lesson 5.4. I hope you followed it and understood it. If you have any questions, please let me know. And I'll see you again for lesson 5.5 on the cosine law.